Good morning, students, and welcome to our lesson about writing parallel and perpendicular equations. So let's get started. We'll start today with our do now, which is a prompt about recalibrating our goals, in other words, readjusting our goals. Often we may have to readjust them downward a little bit just to make them more realistic. Our objective today is to write equations of parallel and perpendicular lines. And our essential question asks, when I am given a linear equation and a certain point, how can I create another equation that passes through that point and is either parallel or perpendicular to the given line? The given line is that original equation that they gave us. This is a highly tested area in algebra on PSAT, SAT, maybe high school entrance exams. You'll see these kinds of questions are very common. So we're going to watch the video and we're going to work these 2 pages. It's a total of 12 problems, but they are a little tricky. So be very careful. So we're going to do an exit ticket where we just have a little reminder about everything we need to remember about parallel and perpendicular lines. We want you to turn your work in Teams by tomorrow morning, please. And you will have homework tonight, which is your homework 4 point, looks like I didn't write it in, 4.10, okay, which is slope and graphing lines review, and that's 12 problems. So let's put our cameras on as much as possible, especially when we're having our classroom discussion. Also, remember to be available. If I call your name at the beginning, middle, or end of the period. I had some great meetings yesterday with some students after school where we got a lot done. Students, start the new year off right. If you're feeling like you're kind of getting behind in algebra, don't let yourself get into a big hole. Reach out and let's make a plan for you to get back on track. Everybody is capable of a B or an A in algebra. It's all about a little bit of focus, a lot of self-confidence, and just simply turning in your work. And I know you can do that. Also, tomorrow, Wednesday, January 6th, is a school holiday. You don't need to tune in. I may not get a chance to remove the invites from the calendars. Y'all can just ignore them. I'll see you Thursday. Remember, we've got a unit test coming up on January 14th and 15th. I have alternative assignment available. Some students have asked to work with a partner, and I'm considering that. Also, very important, beginning the 13th of January, so this is the following Wednesday, a week from tomorrow, we're going to be coming to school all day. So, but you will be doing so from home for the month of January, but you'll log in to each class just like you do when you're at home in the hybrid cohort. We will use our whiteboards during virtual class. So if you don't have one, please send me an email, okay? I gave everybody a whiteboard and dry erase marker. It's possible if you were a 100% distance learner, you may not have gotten it because I got those after I gave you the notes. But you absolutely need to get a hold of me, and we need to make sure you have that. So email me if you don't have that whiteboard and a couple of dry erase markers. We've got enough for everybody in algebra. Okay, so sticking with kind of our New Year theme, our question talks about recalibrating or readjusting our goals. Sometimes reaching a goal can be more difficult than anticipated. It can be harder than you thought it would be. So the goal needs to be recalibrated or adjusted, and you have to adjust your expectations. Now, here's the question: is this failure or progress? And let's think about this. Let's think about it in the context of I talked yesterday about weight loss as a goal. There are plenty of other wonderful goals, though. But, let's say I want to lose 10 pounds by Valentine's Day, and instead I only lose 5. Have I failed? And I think most of you, if I said, oh gosh, I'm such a failure, I only lost 5 pounds, I'm sure most of you would say, well, Mrs. Gold, you didn't fail, you lost 5 pounds. That's a success. It wasn't the exact success you had planned, but, just adjust your thinking. And am I going to be more likely to keep going on with everything I'm doing to try to lose weight if I'm feeling more successful or if I'm feeling like a failure? So what I could do is just readjust. Okay, 10 pounds was too much, but I lost 5. Let's lose another 5 in the next few weeks. And that's a more realistic way. When you don't reach a goal, as long as you're working toward it, it's never failure. Reaching towards something, getting towards something, that is always progress, and progress is always success. So let's not set up difficult expectations that we can't reach. Let's set up realistic goals. And that's why I say some of you who are struggling right now in algebra and you got a little behind, make sure you reach out to me because we can develop a plan to get you back on track. It's nobody's goal here that you don't get a good grade in algebra. I know you feel that sometimes, but that's really not the case. So whatever your goal is, if you just want to get with me and talk about some other kind of goal you have, hey, that's great. Let's strategize ways for you to reach your goals, but in ways that are comfortable and sustainable and reachable. So please take a minute and write something down about this and give it a little thought, because it's when you give it thought, you really grow and you improve. So we'll get back to our parallel and perpendicular lines later. But let's start with writing these equations. So our topic is writing parallel and perpendicular equations. So what is it we're doing here? Because it can get a little confusing. So we are given. So, okay, given means, the assignment gave us a linear equation. That's the equation of a line. And we're given a certain point. Okay, remember the point is going to be in this form, x, y, okay? So we're going to have an equation and a point. Well, we can create another equation that passes through this point and is either parallel or perpendicular to this given line already given to us. Remember, parallel and perpendicular. Let's do perpendicular with another color. So that's parallel, here's perpendicular, okay? So what do we remember from yesterday? Parallel lines have the same slopes. Perpendicular lines have negative reciprocal slopes. And let's talk about methodology. But remember, negative reciprocal, if a fraction or if anything is already negative, let's say you have a negative 2. Okay, well, what's the negative reciprocal of negative 2? Well, we can think of negative 2 as negative 2 over 1, when we would flip that to give us 1/2. And instead of a negative, we would have a positive. So the negative reciprocal of negative 2 is 1/2. So let's talk about what we're going to do, and let's use the whiteboard. So what are we doing? We're writing parallel and perpendicular equations. We are given an equation of a line, and we are given a point. Now, let's start with just the parallel equations first, okay? We'll start here. So, we could be given an equation and a point, and we have a methodology. Step 1 is determine the slope of the given equation. Step 2 is to use the slope and the point by substituting those into the point-slope formula. And this is the point-slope formula here for those of you that may have forgotten. And then the new equation will be in slope-intercept form. So what does all that mean? Let's do an example. So we have negative 2, 3 is our point. Our equation is y equals negative x plus 4. So first we have to determine what is the slope. Okay, step 1, determine the slope of the given equation. Well, we've got an invisible 1 here. So our slope, or our m, equals negative 1. Okay, step 2 says use the slope and the point by substituting into the point slope formula. Okay, so we've got a slope of -1, so we're going to substitute that for the m, and we're going to consider this point here. This is going to be our x1, y1. So we're going to substitute the y1 value and the x1 value. So let's go ahead and do that. So we will have, as we make that substitution, y minus y1, which is this 3, equals m, which is our slope. That's our substitution. So that's -1. That will become invisible, but we can write it in. It's okay. Okay, times the quantity of x minus x1, and our x1 is a -2. Okay, but when we subtract a negative, we make it positive. So that will become x plus 2. And then this becomes an invisible 1. So then we just solve this. So first we distribute. So we have y minus 3 equals -x. -1 times +2 is -2. Now we add 3 to both sides of the equation, and y equals -x plus 1. And that's our final answer. Remember, we were asked to write an equation that has the same slope as this equation and uses these points. Now, let's take a look at Desmos to see what we've done. So I've got the first equation right here. I have in red, you can see it over here. This is our y equals -x plus 4. And the equation that we ended up with is y equals -x plus 4. Now look at those. They are absolutely parallel, and they absolutely have the same slope. They have a slope of -1, a rise of 1 over 1. Now remember, the problem asked us to make sure that the line contained the point -2, 3. So I'm going to go to -2, and look at that. I have the point -2, 3. Exactly, whoops, there we go, exactly as I needed to, exactly as the problem required. So there's my parallel line. So let's do an example with the perpendicular lines. So now we've got perpendicular equations. Again, let's review what the directions are, what the strategy is going to be. We will first determine the slope. Okay, now here's where it changes. When we need to write a perpendicular line, when we're asked to write a perpendicular line, we need to take the slope that we're given in step 1, or that we determine in step 1, and we need to find the negative reciprocal. So that's that extra step. Then, just like the parallel lines, we need to plug the negative reciprocal and the point, so the new slope. Okay, the negative reciprocal is the new slope. We need to plug that into the point slope formula, and our new equation will be in slope-intercept form. So let's work with this example. I'm given the points -2, -2, and that's my x1, y1, and I'm given the equation y equals 1/5 x plus 9. So this slope as given is -1/5. So we need to determine the negative reciprocal of -1/5. Well, the reciprocal of 1/5 is 5 over 1, which equals 5, and the opposite of negative is positive. So the negative reciprocal of -1/5 is 5. So we're going to go with m equals 5. So next thing we do, so we did step 1. We wrote the negative reciprocal and we came up with a slope of 5. Now we're going to plug the negative reciprocal and the point into the point slope formula. So we will have y minus y1. Well, what is my y1? My y1 is 2, but y minus a negative 2 is the same as y plus 2 equals the slope, which is 5, times the quantity of x minus x1. So x minus x1, well, my x1 is a negative 2. So minus a negative is a positive. So that would be x plus 2. Now, the next thing I need to do is distribute. That will give me y plus 2 equals 5 times x is 5x, 5 times 2 is 10. They're both positive. Now, the next thing I want to do is subtract 2 from each side of the equation, which will give me y equals 5x plus 8. So this is our final answer. And if we've done everything correctly, y equals 5x plus 8 should be a line that is perpendicular to y equals negative 1/5 x plus 9. So let's take a look at Desmos and see how we did. I'm going to turn off the first two equations. And here's our given equation. Pull it down a little bit. Our given equation is y equals negative 1/5 x plus 9. Our perpendicular equation that we determined is y equals 5x plus 8. And we needed to make sure that it contained the point negative 2, negative 2. So let's move this up there. It is definitely looks perpendicular. Those would be right angles. And we're looking for the point negative 2, negative 2, and there it is right there. Our line contains the point that it was supposed to, whoops. Let me get exactly to that point so you can see, there it is. Our line contains exactly the point that it was supposed to contain. There we go. Hope you can see that. Okay, so again, let's take a look at that. Those two lines, the green one, the given line, the purple line, the line that we created through our algebraic tools, are those two are perpendicular. So let's get to our work for today and work on our worksheet. So we are asked in the first problem to write the equation of the line that passes through the point negative 2, 7 and is parallel to the line y equals negative 4x plus 1. First, we determine the slope. So the slope here equals negative 4. So write that down first. Then we're going to go ahead and use the point slope formula. I'll write that over here. Y minus y1 equals m, the slope, times the quantity of x minus x1. So we'll start y minus 7 equals m, which is negative 4, times the quantity of x minus negative 2, which is plus 2. Now we distribute. Y minus 7 equals negative 4x minus 8, and we add 7 to both sides, and y equals negative 4x minus 1. And that's our final answer. And we have written the equation of a line that passes through the point negative 2, 7 and is parallel to y equals negative 4x plus 1. So let's go on and do another one. We'll do two of each type and then see if you can try a few on your own. So now we're going to write an equation of the line that passes through the point 3, -1 and is parallel to the line x minus 3y equals 9. Well, first thing I want to do when I see that is I want to get that standard form equation. That's in standard form. I need to put that in slope-intercept form. So I'm going to first move x over, so I'll have -3y equals -x plus 9. Okay, I'm writing the x before the 9 because I want to end up at y equals mx plus b form. Next, I divide everything by -3, which will give me y equals, this is an invisible 1 here, and negative divided by negative is a positive. So we have 1/3 x. 9 divided by -3 is -3. So y equals 1/3 x minus 3. Our slope equals 1/3. Okay, halfway there. Now we're going to write the equation, the point slope, form of the equation, substituting m equals 1/3 for slope and using the points 3, -1. So first we'll have y minus y1. So y minus -1 is y plus 1 equals our slope, 1/3 times the quantity of x minus x1, which is our 3. Then when we distribute, we have y plus 1 equals 1/3 x, and 1/3 times -1 times -3, is -1. Then we just subtract 1 from each side, and we end up with y equals 1/3 x minus 2. -1 minus 1 is -2. And if you were to graph these on Desmos, that's a great way to check your answer. First, you graph the first line. I would graph it in slope-intercept form, and then graph the new line, and you'll see that they're parallel. So let's go with a couple of perpendicular examples. So number 3 asks us to write the equation of the line that passes through the point 4, 3 and is perpendicular to the line y equals 2x minus 4. This is already in slope-intercept form, and our slope is 2. Now, if our slope is 2, what's the negative reciprocal? Well, 2 can be thought of as 2 over 1, and the negative reciprocal of 2 over 1 is -1/2. So the slope that we're looking to write an equation of is going to be -1/2. And we're going to use the point 4, 3. So let's make our substitution. Y minus 3, which is our x1, y1 over here. So y minus 3 equals -1/2 x minus the point 4, the x value of 4 in this point. Now we distribute, and we have y minus 3 equals -1/2 x, and -1/2 times a positive 4 is +2. Now we add 3 to each side of the equation, and we end up with y equals -1/2 x plus 5. And that's our final answer. And then for number 4, we need to get this equation into slope-intercept form first. So first I'll move the 5x to the other side of the equation, which makes it negative. And this is a -21. Then we'll divide everything by 3, which gives me y equals -5/3 x minus 7. Now, we have a slope of -5/3. What's the negative reciprocal of negative 5/3? It's a positive 3/5. Now we'll use the point slope formula and make substitutions for these points and for the slope. So y minus y1, which is our 1, equals the slope of 3/5 times the quantity of x minus negative 5. When you subtract a negative, it's the same as adding. Now our our distribution will give us y minus 1 equals 3/5 x, and 3/5 of 5 is 3, and positive times a positive is a positive. Add 1 to both sides so I can isolate y. Y equals 3/5 x plus 4. And again, if you were to graph this equation, probably do the slope-intercept version, and this equation on Desmos, you would see that they are perfectly perpendicular. So I hope you can try the next few examples. Try a few on your own. I will do all of the examples in the video, but I would like you to try a few on your own. So the next 4 are parallel examples. So go ahead and pause the video and try those, and then I will do them for you. You can check your work. Okay, so let's keep working here. We need a line that is parallel to y equals 2x plus 4 that contains the points -4 and -1. So I'm going to have to be careful of those negatives, first of all. And I notice, first of all, that I have a slope of 2. So y minus -1 is y plus 1 equals 2 times the quantity of x minus -4 is plus 4. Now I distribute. Y plus 1 equals 2x plus 8. I subtract 1 from each side of the equation, and y equals 2x plus 7. All right, number 6. Our slope is -1/4. And our point is 8, 3. So we'll start with the point slope formula. Y minus 3 equals -1/4 times the quantity of x minus 8. Let's distribute. Y minus 3 equals -1/4 x, and -1/4 times -8 is a positive 2. Add 3 to each side of this equation, and we have y equals -1/4 x plus 5. Number 7. We have to put, this is in standard form, we have to put it in slope-intercept form. So the first thing I'll do is move x to the other side, which will give me -2y equals -x plus 14. And then I need to divide everything by -2, which will give me y equals negative divided by negative is a positive, so it's going to be a positive. This is an invisible 1. Positive 1/2 x minus 7. And now I have a slope of 1/2. That's why I did that. I needed to find out the slope. Now I'll use the point 4, 5. Y minus y1, which is 5, equals our slope 1/2 times x minus x1, which is 4. I think I'm going to change my color here. Let's distribute the 1/2 through to the quantity in parentheses, which gives us y minus 5 equals 1/2 x minus 2. 1/2 times -4 is -2. And then we add 5 to each side of the equation, which will give us y equals 1/2 x plus 3. And that's the final answer. And in number 8, we are going to write an equation that's parallel to 5x plus 2y equals 10 and contains the point -6, 7. But first, we'll write this equation in slope-intercept form. We'll start by moving 5x to the other side. So that'd be 2y equals -5x plus 10. We'll divide everything by 2, which gives us y equals -5/2x plus 5. Okay, our slope is -5/2. So let's, I think I'll change the color. We'll use the point slope formula. Y minus 7 equals -5/2 times the quantity of x plus 6. It's x minus -6, so that would be plus 6. Now we distribute. Y minus 7 equals -5/2 x. -5/2 times 6, +6, is -15. Now we will add 7 to both sides of this equation to isolate y, and y will equal -5/2x minus 8. And that's our final answer. So we have 4 more problems, but this time we're looking to write perpendicular lines, a line that is perpendicular to the given equation. So we need to make sure that when we find the slope, that we then determine the negative reciprocal. So the slope in the first example, we have a point of 3, -3, and the slope is 3/4. The negative reciprocal of 3/4 is -4/3. So let's go with our point slope formula. Y minus -3 is y plus 3 equals -4/3, the negative reciprocal, times the quantity of x minus our x value here, which is 3, and then we distribute. Y plus 3 equals -4/3 x, and -4/3 times -3 is a +4. So now we subtract 3 from each side of the equation, and then we're left with y equals -4/3 x plus 1. And if you graph this line and this line, you will find that they are perpendicular to each other and that they contain the point 3, -3. Okay, number 10. We have y equals x minus 2, so our slope is 1. Negative reciprocal of 1 is -1. And we have the point -3, -2. So be careful with those negatives. Y minus -2 is y plus 2 equals -1, and that can be an invisible 1, but just go ahead and write it in, times the quantity of x minus -3, which is x plus 3. And then distribute that -1 to give us y plus 2 equals negative x minus 3. Negative 1 times positive 3 is minus 3. Subtract 2 from each side, and we are left with y equals negative x minus 5. And that's our final answer. There we go. Okay, number 11 is in standard form, so let's fix that. We will move positive 2x to the other side to give us 10y equals negative 2x plus 20. And then we'll divide everything by negative 10 so that we can isolate y. Y equals negative 2 over 10 is the same as we'll simplify it to negative 1/5 x, and 2/10, 2 divided by 10, is going to give me 1/5. So let's see. Oh, I know what I did wrong. My bad. This is a 20, not a 10. So that would be 20 divided by 10, which is a positive 2. Okay, the slope here is negative 1/5, which means my negative reciprocal of 1/5 will be positive 5. So I'm going to move over here in this blank space on the left so we have a little more room. So we'll insert the points and the slope into the point-slope formula. Y minus 3 equals 5 times the quantity of x minus 2. And then we distribute. So we have y minus 3 equals 5x minus 10. And then we'll add 3 to both sides of the equation for a final answer of y equals 5x minus 7. And that's our final answer. And the last problem, we have to move x over, so we'll have 3y equals negative x plus 6. Divide everything by 3. Which will give us y equals negative 1/3 x plus 2. And the negative reciprocal of negative 1/3 is 3. So we'll plug that in and we'll have, I'm going to change the color so it stands out a little better. Y minus y1, which is negative 6. So y plus 6 equals 3 times the quantity of x minus negative 1, which is x plus 1. And now we distribute through the quantity in parentheses, and we are left with y plus 6 equals 3x plus 3. And we subtract 6 from each side to get y equals 3x minus 3. So positive 3 minus 6 is minus 3. And that's our final answer. Remember, you can check all of these by using Desmos. So you worked hard. Let's go to our exit ticket. So I just want you to remember, parallel lines have the same slope. Perpendicular lines have a negative reciprocal slope. You've worked very hard today, students, and don't forget to turn your work into teams. And I promise you that your hard work will reward you in high school, if you go on to college, and then with the many, just thousands of things you can do with everyday algebra. So keep practicing. You have homework number 10 for tonight. It's one page. It's 12 problems. Hint, hint, hint. Two of those problems I did for you in the example that we did earlier in the lesson. So you might want to refer back to that when you do your homework. So keep on practicing, because as you do, you'll be great.